Okay, so we are going to finish up the discussion on your urinary system. And we've talked about all the structures that we have within the kidney and the structures that we have within that nephron. And now, once that urine is formed, or the process of how urine is formed, is where we kind of need to put our focus. So, looking at the process of urine formation, there are three major steps to this entire process. One is glomerular filtration. The second one is tubular reabsorption. And then the last one is tubular secretion. So, in taking you through the parts of the nephron, I've honestly kind of stepped you through these three as well. I just didn't use those terms as we went through that because I wanted to be able to focus on the nephron itself. So, if you go back to one of the pictures of the nephron that has the entire structure with the capillaries running over it, and you have a couple different pictures, either one of them will work. But when we talk about urine formation, the first thing that has to happen is glomerular filtration. And glomerular filtration is going to happen within that glomerulus. And that is simply you have the renal artery that is bringing that blood into the kidney. Blood's going to get delivered to the nephron. And as it makes its way into the nephron, first place it goes is that glomerulus. And those blood vessels are designed to apply pressure to that blood so that you can force out almost everything from the blood. And I've already talked about proteins. They're too big. They don't get filtered out. Red blood cells do not get filtered out. You would never want to see blood in your urine. So something's going on if you can. The other materials that are getting forced out of the blood are small enough that they will fit through the holes in the spaces in those blood vessel walls and then into that glomerular capsule. Anything that is forced out of the blood is called filtrate. And so that's why we call the process glomerular filtration. Happens in the glomerulus and it is forming filtrate. Filtrate at that point still has to be processed. So it's a situation where all of that stuff that was forced out of your blood is now going to be analyzed and sorted. And as it is sorted, your body determines what it can use again and what needs to be eliminated. So it will go through that process of sorting it out into a good category and a bad category. Anything that is in the good category is going to make its way, and this happens within that nephron loop, is going to get pushed out of the brown tubules. And like I said, those capillaries are right there, crisscrossing, running all over the nephron, so that when it is pushed out, it is going to be pulled back into the bloodstream, and that is called tubular reabsorption. Reabsorption is the body's way of taking back any material that can be reused, recycled, or still has some benefit to the body. Happens in that nephron loop, moved out of those brown tubes, pulled into those capillaries, and now that good material is back in your bloodstream and can be recirculated back to your cells. The third one, tubular secretion. So this is going to be that very last part. Tubular secretion is going to be the material that is going to exit the body. So as we get into that collecting duct, that is what is going to be secreted or voided from the body the next time that you go to the restroom. Now the filter rate, it gives you the explanation at the top that water is filtered out of the blood at 125 milliliters per minute. And if we were in a face-to-face setting, I would honestly have you go measure out 125 mils so that you see what that looks like. Because 125 mils, kind of difficult to imagine, but kind of gives you an idea, like I said, if you can measure it out and see it sitting there in a beaker. 125 mils every minute, and that is done 24 hours a day. Your kidneys do not get a rest. And so if you think about what you do to your kidneys, if you don't drink water throughout the day, and we always talk about those 8 glasses of water, and 8 glasses at 8 ounces, 64 ounces throughout the day, but that needs to be spread out over the entire day. A lot of times people will try and get that water in, but they do it in a very short period of time. They'll sit down and they'll drink a whole liter all at once. Well, if you look at that first statement, you are filtering out 125 milliliters per minute all day, every day. If you drink a bunch of water all at once, you're not doing your kidneys any favor. Your body needs that spread out over a very large period of time, obviously not over 24 hours, you can't do that, but to spread that out so that you can help your kidneys through that process of what they're doing all day long. With that total amount, you have 98% of it that is going to be reabsorbed. Here's your assignment. Your assignment is to fill in the blanks. So I gave you the conversion rates of what a quart is, what a gallon is, that 98%, 125 mils per minute, 24 hours a day. So what I want you guys to do, part one, is I want you to tell me how much total volume your kidneys filter out in a single day. Okay. So how many liters of material or how many gallons of material, you can give it to me either way, is filtered out by your kidneys every single 24-hour period? And then how much do you actually void out of your body, keeping in mind that 98% is going to be reabsorbed? Okay. Don't cheat this. Okay. So please don't just Google that answer. Use the numbers that I gave you, because if you Google it, this is one of those things that different resources put different values on it, different numbers on it. You will get a wide range of answers if you look at it that way. Use the numbers I gave you. Okay. I'm going to be very specific on this answer based on the number of values that I gave you. So make sure that you're not just doing a quick Google search, but that you actually use the values I gave you and work that out. The last one on there says each minute 20% of your blood volume is directed to blank. The remaining 80% is directed to blank. That is part two. So your homework assignment is to complete that and send that to me, and I will make a space available within the grading system for you guys to be able to do that. So work it out, get your numbers, and then I will have a place for you to actually upload that to me specifically. The next slide talks about the makeup of urine. And when we look at the makeup of urine, I don't think anybody is too surprised to see that a large majority of that is going to be water. Makes sense. But you don't want to eliminate any more water than what you actually need to. So again, that's the brain's way of monitoring and making sure that you are only eliminating what you absolutely have to. And that's why the concentration or the color of your urine will change. If your brain determines that you need to hang on to some water, it will actually tell your kidneys to pull water out. So in that filtration process, water volume is going to be forced out of your blood, and then it will pull some of that water back in. If your brain determines that you need to pull a lot of that water back in, it makes your urine more concentrated. So if you're not giving yourself enough water and your brain says, hey, we've got to pull some of that water content back out of that filtrate, pulls it back into your body, which makes your urine very concentrated, you're going to see a very dark yellow color. If you are putting plenty of fluids into your body, now the body realizes, or the brain realizes, it has enough fluid. It will tell your kidneys it's okay to release some of that excess fluid, and it will leave that extra fluid in your urine, which dilutes it and makes it a much lighter color. Okay. So a lot of it is water content, but the coloration of it will change just because of how much water you guys have in your system. I don't know if you can hear my kids in the background. Now, the other materials that you have in your urine are things like urea, and urea is going to be what makes your urine yellow in the first place. This is also what is excreted in your sweat. And when you sweat, if you have white clothing on, not uncommon to see yellow stains on white clothing. That is because of that urea that's coming out through your sweat, gets deposited on the clothes. One thing, and I didn't talk about it specifically when we were talking about filter, but there are some things that you should never see in your urine or should not have in your urine. Obviously, blood is one of them. I did mention that, but the other one is glucose. You should never have glucose in your urine. That should always be something that is filtered out and pulled back into your bloodstream. And so, if you have glucose that is showing up in your urine, it's an indication that you have way too much in your bloodstream, and that's the only way that your body has to get rid of it is through your urine. A very good indication of diabetes. Last couple of slides that we have talk about the structures a little bit more specifically. The ureters, you have two of them. They extend from the medial side of the kidney down to the bladder, and you're looking at about 25 centimeters in length. So they're thin little tubes. They collect that urine, and then they will transfer that down to the bladder. But as I mentioned earlier, it is a drop by drop. It's not like urine is constantly funneling down those ureters to the bladder, one drop at a time until it eventually collects. It will move down to the bladder. Bladder is going to be a body part that can expand when it needs to. And so as it's collecting that urine, it will start to stretch out to accommodate that building fluid. Average bladder can hold about 13 ounces. Again, average. Some people can hold more than that, other people not that much. But at 13 ounces, somewhere in that neighborhood, you're going to have collected enough fluid that the nerves inside the bladder are going to be stimulated. And when they are stimulated, that causes the muscle lining around the bladder to contract. And when that muscle contracts, that is your indication that you have to go to the bathroom. As more of those nerves become stimulated, the sensation that you need to go to the bathroom will become increasingly stronger until you can't ignore it and you have to go to the bathroom. The picture that you guys have there shows side-by-side anatomy of the male and female. The female is on the left-hand side, picture A. The male is on the right-hand side, picture B. And the reason that I put this particular picture in is because of the urethra. Find the urethra in the female, find the urethra in the male. One thing that you should notice very quickly, the urethra in the female, much shorter than the urethra in the male. Female urethra is about 3 to 5 centimeters. I did say centimeters, want to clarify that. 3 to 5 centimeters in length. The urethra in the male, 7 to 8 inches in length. So you have a very large difference in the length of the urethra. This is the tube that is going to take the urine from the bladder and void it out of the body. This is how you eliminate it from the body. Now, the reason that I point that out is because, and this is in your last slide as well, but a lot of times, especially when you have a child that you are trying to potty train, you have to take this into consideration because part of controlling when you go to the bathroom is muscle control. Think about those little guys. Somebody first hands you a little guy, and the first thing they tell you, hold their head, support their head, because their neck muscles are not developed enough to do that. We talked about breathing, that diaphragm. Little guys look like they are hyperventilating because that diaphragm is not developed enough to regulate the process of breathing. It also translates to this as well. Until those muscles are well enough developed to be able to constrict and hold that urine in place until you are able to get to the restroom, they can't control that. So they have to get to a point where those muscles are strong enough, those muscles are well developed, that they can regulate when they relax those muscles and allow that urine to leave the body. When you have 3 to 5 centimeters to control versus 7 to 8 inches, it would make it understandable why guys might need a little bit more time before you start potty training. This is not a gender slam. It is anatomically suggested, and you guys can see the reasoning behind it. So that 3 to 5 centimeters, it's going to be plausible that it's easier for them to gain control, females to get control a little bit quicker than guys that have that 7 to 8 inches worth of muscle development that they need to get in order to regulate that process. So something to keep in mind when you have kids. Might want to give, if you have little guys, give them a little bit longer before you maybe start trying to potty train them, just so physically they are in a good place to do that. Again, doesn't hold true for every child. You know, there are differences, there are averages, things like that. So might be a little bit different for one kid to the next, but just a suggestion. So that takes us to the end of this particular discussion. As I mentioned, there will be a place for you to upload those answers. There are 2 different answers that you have to give me. There's a part 1, which you need to identify how much is filtered in a 24-hour period total. And then 98% of that is going to be pulled back in. So how much is actually going to be eliminated from the body? And then the second part, that 80-20 question. So you need to answer those and get those uploaded. And I will put the due date on those. So when you pull that up, it will let you know exactly when you have to have that completed by. If you have any questions, send me an email and I will get those taken care of for you as soon as possible. And again, I hope this finds everyone doing well.